Over the next 40 years, humanity will pour over $1 trillion into just 7 construction projects. Projects so extreme they could wipe out entire cities, pierce through the clouds, and even recreate the sun's temperature on Earth. And no, these aren't sci-fi fantasies or billionaire fever dreams. They're real, and they're being built right now. So, let's dive in. Number 1. ITER Nuclear Fusion Reactor. First up is ITER, the International Thermonuclear Experimental Reactor. Located in Saint-Paul-les-Durance, France, this massive project is attempting something no other power plant has ever done: creating a miniature sun on Earth to unlock unlimited clean energy. Unlike nuclear fission used in today's power plants, which splits atoms, ITER uses nuclear fusion, the process that powers the sun, to fuse atoms together. Think of it like squeezing them, releasing enormous amounts of energy with minimal waste. If successful, fusion could revolutionize energy forever by providing a near-infinite power source using just seawater as fuel. At $65 billion, ITER is the largest fusion experiment ever attempted, with a plasma volume 6 times larger than any previous reactor. It's designed to reach 150 million degrees Celsius, 10 times hotter than the sun's core, and produce 10 times more thermal energy than it consumes. But hold on, ITER isn't meant to generate electricity. It's purely a research project, paving the way for future commercial reactors like DEMO, which could power cities in the future. Its construction kicked off in 2013, with reactor assembly beginning in 2020. As of 2025, 75% of the components have been installed, but progress hasn't been smooth. Cracked thermal shields, misaligned vacuum vessel segments, and radiation safety concerns forced ITER to halt assembly in 2022. COVID-19 delays, falsified welder certifications, and budget disputes between the 35 participating countries have only added to the setbacks. Speaking of delays, the first plasma test, originally scheduled for 2025, has now been pushed to 2034, with full fusion experiments not expected before 2039. At this rate, our grandkids might be powering their flying cars with fusion energy, if we're lucky. But there have been some wins. In 2024, they revised their schedule to focus on completing the reactor for experiments. Meanwhile, the JET reactor set a new world record for fusion energy output in 2025, validating ITER's design. Engineers have even upgraded the reactor's first wall from beryllium to tungsten to handle extreme temperatures better. If ITER succeeds, it could change energy as we know it, using deuterium from seawater, an abundant resource, to produce nearly limitless carbon-free power with minimal waste. But there's a running joke in the scientific community. Fusion energy has been 30 years away for the past 40 years. ITER is humanity's biggest bet on proving large-scale fusion can work, but success isn't guaranteed. And here's the twist. ITER isn't the only fusion project racing toward this goal. While ITER is a global effort, private companies like Helion and Commonwealth Fusion Systems claim they could deliver fusion power before 2035 using smaller, more efficient designs. So, will ITER be the breakthrough that transforms energy forever? Number 2. Jeddah Tower. Speaking of delivering, let's talk about a tower that's about to deliver something unprecedented: the world's first building to pierce the 1-kilometer mark. The Jeddah Tower in Saudi Arabia is set to stand at 1,008 meters, surpassing the Burj Khalifa by 180 meters and becoming the world's tallest skyscraper. This $1.2 billion megaproject, part of the $26 billion Jeddah Economic City development, was designed by Adrian Smith and Gordon Gill, and its 3-petal shape takes inspiration from desert plants, but it's not just for aesthetics. The design is crucial for mitigating intense desert winds, reducing vortex shedding by 30% compared to traditional skyscrapers. To survive Jeddah's extreme climate, the tower incorporates reinforced concrete, heat-resistant glass, and advanced structural supports engineered to withstand scorching temperatures, sandstorms, and extreme wind loads. As of late 2024, construction has resumed after years of delays. The tower stands at about 250 metres with 63 floors completed, but overall progress is estimated to be 76% complete, far from the originally planned opening date. The goal is now to finish by 2028, though some sources suggest it could stretch to 2030. But getting here hasn't been easy. The project hit a 5-year pause, 2018 to 2023, due to a mix of political turmoil, COVID-19, and financial struggles. In 2017 and 2018, several key figures, including the chairman of Saudi Bin Laden Group, the lead construction company, were arrested during Saudi Arabia's anti-corruption crackdown. Add in contractor disputes, funding problems, and construction halts, and it's easy to see why this tower has taken over a decade to rise. And when we say vertical city, we mean it. The tower will have 167 occupied floors out of 252 total levels, packed with luxury apartments, offices, a shopping centre, and what was originally planned as a Four Seasons hotel. It will also feature the world's highest observation deck at 652 metres, offering breathtaking views from nearly twice the height of the Empire State Building. To keep this sky-high metropolis running, the tower will use 59 high-speed elevators, including double-deck systems to efficiently transport people to different levels. The Jeddah Tower is part of Saudi Arabia's Vision 2030, an ambitious plan to diversify the country's economy beyond oil and transform it into a global tourism and business hub. But will Jeddah Tower actually become the world's first kilometre-high skyscraper? Or will it remain an unfinished monument to Saudi Arabia's ambition? Number 3. Megabuilds Hydropower Station. But while Saudi Arabia is building up, China is digging deep into the earth for our next megaproject. If you thought a kilometre-tall tower was impressive, wait until you hear about a dam that's being built in the world's deepest canyon. At $137 billion, it's more than twice as expensive as the Jeddah Tower and ITER combined. With a total capacity of 60 gigawatts, it's designed to power 300 million homes and stands as a cornerstone of China's commitment to reaching carbon neutrality by 2060. The dam's location in the Yalong-Zangbo Grand Canyon presents some of the most extreme engineering challenges in history. The canyon plunges to depths of 5,000 meters, with the river dropping 2,000 meters over a mere 50-kilometer stretch. This intense water flow makes the location perfect for hydropower, but it forces engineers to drill 20-kilometer tunnels through the world's deepest canyon. Adding to these challenges, the dam sits in a seismically active region near a major tectonic plate boundary. A recent 6.8 magnitude earthquake in Tibet has raised serious concerns about the structure's ability to withstand major seismic events. The project's risks extend far beyond engineering challenges. China controls about 50% of the Brahmaputra River's flow, and this dam has sparked intense opposition from India and Bangladesh. These downstream countries fear their water supply and agricultural systems could be severely impacted. India's designation of the dam as a water bomb reflects their concern that China could manipulate the river's flow, or worse, that a structural failure could trigger catastrophic flooding across multiple countries. The environmental and social costs are equally staggering. Local Tibetan communities face displacement, and the construction threatens one of the world's most biodiverse regions. The Tibetan Plateau's delicate ecosystems, home to numerous rare plant and animal species, stand to be permanently altered by this massive intervention. Despite these challenges, China is forging ahead with the project as part of its 14th five-year plan. The dam represents a key component of China's ambitious $1 trillion investment in renewable energy and infrastructure, scheduled for completion by 2060. If successful, it will be an engineering marvel that transforms the region's energy landscape. But here's the real question: can China actually pull this off? If you want to dive deeper into this massive project, check out our full video on China's Himalayan megadam. Number 4. California High-Speed Rail. While China is constructing the world's largest dam, across the Pacific, the United States is attempting its own megaproject. But instead of reaching for the skies or burrowing into the earth, this one is racing across the land. The California High-Speed Rail is the country's first true high-speed rail system, an ambitious $128 billion project designed to connect San Francisco and Los Angeles, with trains traveling at 220 miles per hour, 350 kilometers per hour. But this isn't just another train system. The plan is to slash travel time between the two cities to just 2 hours and 40 minutes, transforming California's transportation network. However, like many large-scale infrastructure projects, CAHSR has faced delays, rising costs, and mounting skepticism. The network was originally envisioned as an 800-mile system with 24 stations, but today only a 171-mile stretch in the Central Valley, connecting Merced to Bakersfield, is under active construction. This scaled-back approach has drawn criticism, especially since the San Francisco to Los Angeles connection is still years away. It mirrors ITER's constant timeline extensions, leaving supporters frustrated and doubtful of when, or even if, the full project will ever be completed. As of early 2025, construction is divided into 3 major packages. Construction Package 1, Madera to Fresno, total of 32 miles, with 2 miles fully complete, 18 miles under construction, and 12 miles yet to be built. Construction Package 2-3, Fresno to Tulare, Kern County border. Total of 65 miles, 33 miles completed, 16 miles in progress, and 16 miles remaining. Construction Package 4, extending 22 miles to Shafter. Nearly complete with only 400 feet of guideway left to finish. The numbers behind California high-speed rail budget are staggering. The entire 171-mile Central Valley segment alone is now estimated at $35 billion. However, at $205 million per mile, it still ranks among the most expensive rail projects in history. When compared to Japan's entire Shinkansen network, which cost significantly less per mile, California's price tag raises serious questions about cost management. To put things in perspective, the total cost of NASA's Mars Perseverance mission was $2.7 billion, which means you could fund 13 Mars rovers for the price of just one segment of California's high-speed rail. Despite the promise of high-speed connectivity, the full San Francisco to Los Angeles Phase 1 remains a distant goal. Several challenges have slowed construction and increased costs, including land acquisition disputes that have delayed key sections of the route, political and funding battles between state and federal agencies, construction costs that continue to rise, pushing Phase 1 estimates up to $128 billion, blended track sections near urban areas, which reduce speeds from 220 miles per hour to 110 miles per hour, potentially preventing the project from meeting its original 2-hour, 40-minute travel time goal. But it's not all bad news. CAHSR is projected to create over 200,000 long-term jobs, in addition to over 11,500 construction jobs already active. Carry an estimated 8.8 million riders annually in the Central Valley alone, more than double the current Amtrak ridership for that region. While China continues to set records for high-speed rail expansion, California's project is still struggling to get past the first hurdle. With escalating costs, political fights, and construction delays, some critics doubt whether the full system will ever be completed. Will California's high-speed rail ever live up to its promises, or will it become America's most expensive unfinished megaproject? If you want to dive deeper into this project, check out our full video on the California high-speed rail and see why it's America's most ambitious and controversial railway. Number 5. NEOM, the line. While California struggles with a high-speed rail line, Saudi Arabia is struggling with a city that's not a city, but a 170-kilometer-long mirrored wall in the desert. Part of the $1.5 trillion NEOM project, the line dwarfs even the Jeddah Tower in ambition and scale. At 500 meters tall and 200 meters wide, this futuristic megastructure is essentially a skyscraper turned on its side. Saudi Arabia envisions it as a car-free, AI-powered, 100% renewable utopia, housing 9 million people in a compact, hyper-efficient environment. The goal? To reimagine how humans live, commute, and interact. Despite the bold vision, the line has already been scaled back significantly. The original plan called for the full 170 kilometers to be completed by 2030, but now only 2.4 kilometers will be built by that deadline. That's roughly the same length as the completed section of California's high-speed rail guideway. Even the projected 9 million residents seem highly unlikely anytime soon. Updated estimates suggest that by 2030, only 300,000 people will live in the line, down from an earlier goal of 1.5 million. Building this megaproject isn't just about stacking glass and steel. Crews are currently casting over 420 foundation piles per week, but the project faces some of the most extreme scaling and logistical challenges in history. Urban planners question whether a linear city, where everything is arranged in a single row, can function efficiently. And then there's the human cost. Over 20,000 members of the Hawitat tribe have been forcibly evicted, with reports of arrests and even executions tied to the project's land clearance efforts. The UN has condemned Saudi Arabia over these human rights violations. With spiraling costs, ecological concerns, and a completion timeline stretching up to 100 years, the line may remain more of a futuristic experiment than a real city. While its AI-driven transit system promises to get residents from one end to the other in just 20 minutes, critics warn that the sheer scale and isolation could make daily life impractical. Is this the future of cities, or just a $1 trillion mirage in the desert? Only time will tell. Number 6. Huajiang Grand Canyon Bridge. While the line stretches horizontally across Saudi Arabia, China is breaking vertical records once again. This time not by going deep into the earth like the Yalong Sangpo Dam, but by soaring high above it. The Huajiang Grand Canyon Bridge, set to become the world's highest bridge, will stand 625 meters above the Baipan River in Guizhou province, surpassing the Duge Bridge, 565 meters, also located in Guizhou, China, as the highest road bridge ever built. At 2,890 meters long, with a 1,420-meter main span, this $280 million megaproject is a marvel of modern engineering. It will cut travel time across the canyon from 70 minutes to just 1 minute, fundamentally transforming local transportation. But this bridge isn't just about efficiency. It will also feature a glass elevator and a 625-meter bungee jump, turning infrastructure into a tourist attraction. Like the Yalong Sangpo Dam, the Huajiang Grand Canyon Bridge is being built in a seismically active region, requiring unparalleled precision and engineering expertise. The bridge employs AI-controlled cranes and a smart cable crane system using Beidou satellite navigation to hoist 21,000-ton steel trusses, ensuring construction safety at extreme heights. Despite the extreme conditions, progress has been remarkably fast. Since construction began in 2022, over 93 steel truss segments have been installed as of January 2025, with full completion on track for June 2025. While many megaprojects struggle with delays, China's engineering efficiency continues to set global benchmarks. This bridge is part of China's larger strategy to connect remote regions, and Guizhou province now hosts 8 of the world's 10 highest bridges. The Huajiang Grand Canyon Bridge is yet another testament to China's ability to push the boundaries of engineering, speed, and scale, proving that even the most extreme megaprojects can be completed in record time. Number 7. Snowy 2.0 Hydropower Project. Our final megaproject takes us to Australia, where one of the most ambitious energy projects is unfolding beneath the snowy mountains. Snowy 2.0 isn't about building a massive new dam or a towering skyscraper. It's about turning mountains into a giant rechargeable battery to power the country's renewable energy future. But with costs spiraling from an initial $2 billion to $12 billion and completion now pushed to 2028, the question remains, is this mega battery worth it? Think of Snowy 2.0 as a massive hydro-powered battery for Australia's energy grid. Imagine two giant water tanks, one at the top of a mountain and one at the bottom. When there's excess electricity in the grid from solar or wind farms, pumps move water uphill to the upper reservoir. Later, when energy demand peaks, the water races back down through a series of 27 kilometers of underground tunnels, spinning turbines to generate electricity, just like a hydroelectric dam. This isn't about creating new energy, it's about storing and releasing power on demand, helping to stabilize the grid and make renewables more reliable. Once operational, Snowy 2.0 will add 2,200 megawatts of energy capacity, supplying power to 500,000 homes during peak demand. The project's construction has been anything but smooth. 27 kilometers of tunnels are being carved through the hard rock of the snowy mountains, with some tunnels reaching 800 meters below ground. The work has been plagued by delays, with tunnel boring machines like Florence getting stuck for weeks. As a result, completion has been pushed to late 2027 for first power generation, with full operations by December 2028. But Snowy 2.0 isn't just about tunnels. It includes a massive underground power station, gigantic steel pipelines, and a complex water transfer system. These components make it one of the most intricate hydropower projects ever attempted in Australia. Like many megaprojects, Snowy 2.0's budget has skyrocketed. Originally estimated at $2 billion in 2017, the project is now projected to cost $12 billion due to inflation, construction challenges, and pandemic-related disruptions. Meanwhile, safety concerns have led to major worker strikes. In January 2025, over 700 workers walked off the job, citing faulty emergency refuge chambers and inadequate training. In response, the project has added new safety measures, but these setbacks have raised questions about whether the final cost will rise even further. Unlike large-scale dams that flood vast areas, Snowy 2.0's operational footprint will cover less than 0.01% of Kosciuszko National Park once construction is complete. However, its construction phase has sparked environmental controversy, including fines for pollution, delays in environmental management plans, and concerns about biodiversity impact. Critics also argue that while the project will store clean energy, it will initially rely on grid electricity, including fossil fuels, to pump water uphill, potentially offsetting some of its environmental benefits in the short term. Snowy 2.0 is one of the most ambitious energy projects in Australia's history. If successful, it will provide reliable, large-scale energy storage, helping to stabilize the transition to renewables. However, with costs ballooning, construction delays mounting, and safety concerns growing, the project has become a test case for whether massive infrastructure can truly keep up with the demands of a rapidly evolving energy landscape. What do you think? Is Snowy 2.0 a crucial investment in clean energy or an overpriced experiment? And if you want to dive deeper into the challenges and future of Snowy 2.0, check out our full video. These 7 megaprojects show just how far humanity is willing to push the boundaries of what's possible. Only time will tell which of these will succeed and which will fall short of their lofty goals. But one thing is certain. They're all redefining the limits of engineering. But now we want to hear from you. Which megaproject do you think should have made this list? Let us know in the comments. If you enjoyed this deep dive into the world's most ambitious megaprojects, make sure to follow MegaBuilds for more stories. Like and share this video to help others discover the incredible engineering shaping our world. Thanks for watching, and we'll see you in the next one.